All right, point 4, where we're going to find the mean, standard deviation, and min and max of unusual values of a binomial distribution and determine if a value is. So assume that a procedure yields a binomial distribution with n trials and the probability of success for one trial. Use the given values of n, the number of trials, and p, the probability of success, to find the mean and the standard deviation. So if n equals 1,655 and the probability of success is 2 out of 5 or 2/5, then use the formula n times p, and that gives you the actual mean. You have a formula as well. You take the square root of n times p times q, where n again is the number of trials, p is the probability of success, and q would be the probability of failure, which would be the same as 1 minus the probability of success. So I just go through a couple of steps to multiply all this out, and then take the square root and round to 1 decimal point. Use the range of rule of thumb to find the minimum, which is the mean minus 2 times standard deviation. So in other words, below the mean by 2 standard deviations, and then above the mean by 2 standard. So we just simply plug in these values that we got, our 662 for the mean, 2 times our standard deviation, and so this would be anything below this we would consider too small. It would be an unusual value by the minimum, and then by the maximum we add our mean plus 2 times our standard deviation, and we get this value. So again, this is good to know what this means. If I have a distribution that looks like this, and my mean's at 662, and I stay within 2 standard deviations of the mean, we're saying that if you got anything out in this area, we would consider that unusual because that's more than 2 standard deviations away from the mean. Several psychology students are unprepared, surprise, surprise, right? For a surprise true-false test with 10 questions, and all of their answers are guesses. Find the mean for the number of correct answers for each. Well, if it's a true and false, you have a 50-50 chance, right? So the probability of getting the correct answer on true-false is 1 out of 2. In other words, you get 1 right out of 2 guesses, or 0.5. So to find the mean, you take the number of trials, well there's 10 questions, times the probability of success, and we get a mean of 5. Find the standard deviation, same formula, square root of n times p times q, where n again is 10 questions, p the probability of getting a true-false right, 0.5, getting it wrong, 1 minus 0.5, which is also 0.5, and I get a standard deviation of 1.6. Would it be unusual for a student to pass by guessing and getting at least 7 correct answers? Well, remember, what we think would be unusual would be more than 2 standard deviations. In this case, if we're looking at 7, mean was below, so we want to add. So our mean plus 2 standard deviations. This 7 is still within 2 standard deviations, so it wouldn't seem unusual at all. If it was above 8.2, like say, what if this asked if it was 9, then that would seem a little unusual because that's more than 2 standard deviations away from the mean.